Not too much to write there? Okay, so polynomial inequality, if we can't isolate the variable because it's in too many terms and they cannot be combined, factor. So, for example, in this is example 5. It says determine where this expression is positive or negative. You can't isolate the x because it's in two different terms and they're not like terms. So what you can do is you factor. And all of these problems will be factorable. How does that factor? X minus 3, x plus 2. Right? So if I want to determine the sign, like when is this expression positive and when is it negative? Well, it's going to matter whether or not these factors are positive or negative. We know that when you multiply two positive numbers, you get a positive number. If you multiply two negative numbers, you get a positive number. But if you multiply a positive and a negative, it's negative. So we got to find the intervals of x where this expression is positive and negative. And there's different ways to do it. I would just say, if we were looking for the zeros of these factors, what would you say? Negative 2 and 3. Okay. In the book, they're calling these critical numbers. Okay, critical numbers. Okay, those are the numbers, not just where those factors equal 0. It's where the factors change sign. Right? I mean, when x is less than negative 2, x plus 2 is negative. But when x is greater than negative 2, x plus 2 is positive. So at these critical numbers, the factors themselves change signs. Okay. So what I would do, there's different ways to do this. And the book doesn't show it exactly like this. Is the way that I was taught a century ago. Okay, there's my number line, and I put the critical numbers on there. And then I take the first factor, x plus 2, and I say, okay, x plus 2 is negative when x is less than negative 2. So I'm going to go in like this. Negatives, and then it's positive when x is greater than negative 2. X minus 3 is negative when x is less than 3. And it's positive when x is greater than 3. So when I look at the product of x plus 2 times x minus 3, okay, when x is less than negative 2, both factors are negative. So the product is positive. It's greater than 0. Right? When x is between negative 2 and 3, one of the factors is positive, but one of them is negative. So it's less than 0. And when x is greater than 3, they're both positive, so the whole thing is positive. And you could notice that at the critical values, the critical numbers, the whole expression changes sign, right? So it's greater than 0, less than 0, greater than 0. So another way that you could solve this, instead of drawing a diagram with all the pluses and minuses, you could just test a value inside one of the intervals. For example, since 0 is between negative 2 and 3, let me see what is the value of this expression when x equals 0. It's negative 6, so it's less than 0. So it must be that this thing is negative in between these two critical values. And it changes sign on either side. So that's another option if you didn't want to like draw a diagram like this. I don't care. Doesn't matter.